This video is over lesson 45, translating between words and inequalities, and it is for my Algebra 1 class. So an inequality is defined as a statement that two expressions are not equal. The prefix in means not. Now, down here I've also provided you a more technical definition for a basic um, inequality. So this upside down A means for all. So for all A, X, and Y, and then this kind of E looking thing means element of, and then we have the real numbers symbol. So for all A, X, and Y that are elements of the real number, and A is a positive number, and I realized, shame on me, I'll have to go back and fix this sometimes. I should have just said A is a positive number instead of A is greater than 0. I really shouldn't use the inequality in its own definition before I've defined it. But A is a positive is all I'm trying to say here. So A is positive. If X plus A equals Y, so if it takes a positive number added with X to get to Y, then X is less than Y. And so essentially what this kind of looks like is happening here is if X plus A equals Y, it looks like we've subtracted a positive number from just one side of the equal sign. Well, you know the golden rule of solving equations is what you do to one side you must do to the other. Well, that's if you want to keep it equal. So if I subtract a positive from one side, then this side will be less than the other side. And now I'm going to tell you right now that this is not going to be particularly important for our lesson or even for our class, but if you can kind of keep this somewhere in the back of your minds for future classes, this is something that may come up as handy, not terribly often, but once every once in a while, that if you can pull it out, you have a shot at really impressing your teacher in the future. But if you don't remember, it's not a big deal. So with that being said, let's move into the actual meat of our lesson. So since we're talking about inequalities, we have 5 basic inequality symbols that we're going to be using here today. And you see them right here. And so our first one here, well, actually, let's start with this one. This right here, so if you think about the inequalities like an alligator mouth, the alligator always wants to eat the bigger number. So that would mean the bigger number's over here, the smaller number's over here. So this number would be greater than that number. So this is our greater than symbol. So if you're still having trouble with remembering which one's which, it works. The alligator example works. At least it's worked very well for me. So over here then, obviously this must be the less than, because if the alligator's eating the number on the right, then the left must be less than the right. So this is our less than. And now I'm going to go back over to the left. So this looks like a greater than, but with half of an equal sign underneath it. And so this is greater than or equal to. And so this is not a choice. This is not an either or. This is just, is this comparison at least one of these? So it's a yes or no question, if you want to think of it in terms of a question. Every once in a while I get students when we're first getting used to greater than or equal to, I'll ask them, is this number greater than or equal to that number? And they'll say, it's greater than. No. The answer is yes or no. So if I say, is 5 greater than or equal to 3? The answer is yes. Yes, it is greater than or equal to 3. And then that's the correct answer though. So it's just asking, is it at least one of these two things? And so then obviously over here then, the less than combined with half an equal sign is our less than or equal to. And in the middle, the equal sign with a slash through it, typically when we put a slash through something in mathematics, that means not. So if this is an equal sign with a slash, this is not equal to. So when it comes to translating between words and inequalities, there are a few things that we need to realize. So one thing we need to realize is that often we use the word is to mean equals. So therefore, we're going to say is not sometimes to mean not equal. Let's put that in quotes. So if you see is not, that's saying that these two things are not equal. Greater than can also be expressed in other terms like more than, taller than, bigger than. So all those kinds of terms can express that greater than there. Less than, likewise, could be smaller than, shorter than, younger than. And now our two on the end are special. So since it's greater than or equal to here, okay, so imagine this was x is greater than or equal to 3. So x can be greater than 3, it can be equal to 3, it just can't be lower than 3. So therefore, that means that the smallest number that x could be would be 3. So when we have a greater than, it's actually, we can actually use the phrase at least. And then in a similar way, if it's a less than or equal to, we might use the words at most. Since it's less than or equal to a number, then that number is the most that it can be. And so these can seem a little backwards because greater than, but we're saying least. Less than, but we're saying most. So they seem a little backwards, but that is correct. Okay. So again, the idea here is if it's a greater than or equal to, then it's telling us that it's greater than or equal to this number. So that number is the least that it can be. Less than or equal to, we're telling you what the most it can be is, because everything else is less than that most. So with that being said, we're going to take these statements here and we're going to translate them from words into math expressions, into inequalities in particular. So we're going to do the first one together. We see here it says an unknown out of 6. So when we see out of, that's going to be different than just plain old of. Now typically of means times, and just about every time I talk about of, when I ask you what it means, the way I say it is it almost always means times. And I say almost always because this is the rare exception. Where when we see out of, really you want to think about this as being like a fraction. So out of, think fraction. So I've got that unknown out of 6. So that's going to be x over 6. So x over 6 is greater than 7. And there's our first one. So ladies and gentlemen, I'm going to ask you at this point to go ahead and pause the video and just try the next one and then hit play, see how you did, and then maybe try the next one again, hit pause, try it, hit play again, see how you did, and then maybe hit pause one more time, try the next two, the last two on the front here, and then hit play and see how you did. So hopefully you've already tried out this first one. I'm going to go for it. So the difference between, so difference means we're subtracting some things. The difference between thrice a number. Now that might have thrown some of you for a loop. So thrice a number, so we know a number is going to be x. So thrice actually means 3 times a number. So thrice a number is actually going to be 3x. So the difference between thrice a number and 4, so the other part of this is 4, is at most, oops, sorry, I had a little typo there. That should have been at most. I hope that didn't mess you up too much. So is at most 10. So at most means that all the rest of these numbers are less than or equal to 10. 10 is the most that it can be. Moving on to the next one. 5 less than a number. So 5 less than a number is less than 3. Lots of less thans there. So first of all, 5 less than a number, this is actually telling us x minus 5. We're going to go 5 less than a number. And then is less than, that's going to be our actual less than symbol, 3. Next one up, a quarter of a number is not negative 8. Now a quarter really is a fourth. So a quarter of a number, this of, it's not an out of, this actually is of, so it's times. So a quarter of a number, I don't know what number, so I'm going to just call it x. And then is not, that's going to be a not equal to -8. And then finally the last one, a number and 2 is at least -1. A number and 2 is at least -1. So a number, x, and is plus. So a number and 2 really means x plus 2. Just like if I say 2 and 3 is 5, well, that's 2 plus 3 equals 5. So 2 plus x plus 2 is at least. So if that's the least that it can be, then I know all the other numbers have to be greater than or equal to this -1. If it's at least -1, that's the least. Everything else is greater than or equal to. So on to the back. We're going to go backwards with this, and this is a little difficult to do on a video. So ideally, this would be best if we were in class looking at this together, so that we could discuss, because there can be more than one right answer here. So I'm going to say go ahead and again pause the video, after an example, give these a shot for yourselves, and then hit play and see how you do. I'm going to give an answer, but it's not necessarily going to be the only possibility. So go ahead and pause and try the first one. All right, so for me, when I look at this, there's a couple different ways we could do this. I might say, I'm looking at that plus 3, and so I might say 3 greater than. And so that greater than actually switches the order of my addition. So I mentioned in the expression the 3 comes second, but in the English the 3 comes first. And then I now see that 2x, and I might make that twice a number. So twice means times 2, and x would be a number. And then since that's greater than or equal to 23, then 23 is the least that this can be. So is at least 23. And that would be my statement. You could also say the sum of twice x and 3. You could say the sum of double a number and 3. So there's a bunch of different ways that you could express this here. Down here, x squared not equal to 14. I would say a number squared is not 14. Now, a word of caution here. One thing that I would not say is I would not say a number times itself. Because if we say a number times itself, then really this should have said x times x. But this doesn't say x times x. Now, it does mean that, but that's not what it says. So it says x squared, so we should say something about squaring something. So a number squared is not 14 is the best answer there for sure. All right, next up. So here, I've already done one where I switched the numbers around by saying greater than. I could again say 8 less than something, but I want to do something a little different this time. Speaking of different, since this is a subtraction problem, I'm going to use the word difference, the answer to a subtraction problem. So the difference, if I use proper grammar though, I suppose I should start with the. There we go. The difference, gotta keep the English teachers happy. The difference between, and then I see 1/2 x. So I'm just going to call that half of a number and 8. The difference between half of a number and 8 is less than 6. Next up, so x over 9 is less than or equal to 4. A few different ways that we could say this one. We could just think of this as division. So a number divided by 9. And since this is a less than or equal to, that means all these values are less than or equal to 4. So 4 is the most it can be. So a number divided by 9 is at most 4. Another way we could do this is just as we talked on the front, we could think of this as a fraction. So a number out of 9 is at most 4. That would work as well. We could also say the quotient of a number in 9 is at most 4. And so finally, the last one here, we have x plus 9 is greater than negative 5. So this one I'm going to throw you kind of an extra loop in there, throw you for an extra loop. So I'm going to say a number and 9 is greater than, and when you look at negative 5, I could just say negative 5, or we could say what that actually means. So it's possible that we could come across something that says greater than the opposite of 5. Because the opposite of 5 would obviously then be negative 5. So do you necessarily have to say the opposite of 5? No, but it's just an option. Which brings us to our last example. So water is frozen if its temperature is less than 0 degrees Celsius. Actually, once you hit 0 degrees Celsius, it works on changing from liquid to a solid. So at 0 degrees, you could have water as a liquid, you could have water as ice. But it starts that transition. So once we get below, it should definitely be ice. Celsius can be converted into Kelvin using the formula C equals K minus 273. So write an expression for the temperatures at which water is frozen in Kelvin. So if we think this through, the problem just told us that when Celsius is less than 0, the water is frozen. But we also know that Celsius equals K minus 273. So just replace the C with what it's equal to. So K minus 273 must be less than 0. Now, we haven't learned how to solve inequalities yet this year, or in these lessons. Eventually we'll get to a place where we'll solve this, but for right now in the book, that is good enough. That's good enough. And that, ladies and gentlemen, is the end of our lesson.